In lesson 2.7, we start graphing inequalities. And when we graph inequalities, there's three usual steps that we'll go through. Anytime you want to make a graph, you need to have points. So step one is going to be treating it as though it doesn't even have an inequality. So I'm going to graph y minus 2 is equal to 3x. Graphing a line, and I know it's a line because everything is to the first power, y to the first and x to the first, is probably easiest when we have it in slope-intercept form. So I'm going to move the negative 2 from the left side to the right side. And if I want to move a negative 2, I'll do it by adding, which gives me y equals 3x plus 2. Why is slope-intercept form an easier type of line to graph? It gives you two important bits of information. The first is the plus 2. The plus 2 is the y-intercept. And by its name, it tells you where it crosses the y-axis. So at 0, 2, I'm going to make my first dot. Then it gives you the slope. This line has a slope of 3, which you can think of as a fraction, 3 over 1. And that tells me to go 3 up from my first point and 1 to the right. I can do it again if I want. Up 3, 1 to the right. So there's step 1. I've created some points. Step 2. I need to decide how to connect those points. Do I want to use a dotted line or do I want to use a solid line? To figure that out, you go back to the original inequality. The inequality says less than. If it had said less than or equal to, the or equal to is the important part, then I would connect the dots with a solid line. Because it does not have an or equal to, I'm going to use a dotted line to connect those dots. Last but not least, step 3. I need to figure out which side of the line to shade. With inequalities, there are a lot of possible points. That's why we use shading to represent those. As long as my line doesn't go through the origin, 0, 0, that's the point I'm going to use to check and see which side to shade. The reason I use 0, 0, when I plug it into my equation, instead of y minus 2, that would give me 0 minus 2. And then instead of less than 3x, it's less than 3 times 0. Plugging in 0 gets things to disappear. On the left side, there's just a negative 2. On the right side, it's 0. Once you've plugged in 0, 0, you have to ask yourself the question, does the statement make sense? Is 2 less than 0? That is a true statement. So I checked 0, 0, which I'll mark with a red dot. That point made sense, so I shade towards that point, which is everything on the right side of my line. Now I have my solution to the original inequality. 26 puts in a slightly different twist. We're graphing the line y is greater than 4x, and we're taking the absolute value of 4x, but our steps stay the same. Step number 1, I need to have points. And I need to have points for y equals and then the absolute value of 4x. With absolute values, you can graph those on your calculator, or you can use a quick little table of values where you pick x's and y's. If I decide to do that, let's say I graph negative 2, 0, and positive 2, just to generate some points on my lines. If x equals negative 2, 4 times negative 2 will be negative 8. Absolute value of that would be positive 8. Plug in 0, you get 0. Positive 2 is positive 8. Now I'll graph those points. So negative 2, positive 8. 0, 0, and then 2, 8. Step 1 is done. Step 2, what kind of line do we want to use to connect those dots, dotted or solid? 26 again does not have an or equal to. If it had, we'd connect them with a solid line, but it doesn't. So here comes another dotted line. And connect them the best you can. Last but not least, number 3. Where do we shade? This graph goes through the origin, so I'm not going to use that as one of my points. I'm going to pick something either on the inside of my lines or on the outside. Let's say I decide to check the point 5, 0. I'll mark it again in red. Let's see what happens when you plug that in. My point is 5, 0. So 0 goes in for y is greater than the absolute value of 4 times 5, which gives me 0 greater than 20. Is that a true statement? Is 0 bigger than 20? It's not. So the point I checked didn't work. That means I shade the other area, which means I'm shading the inside of my graph. Last but not least, you're going to see some story problems, like number 35. The situation here is that tickets for Prestonville High School Dramas Club Spring Play cost $4 for adults and $3 for students. In order to cover expenses, at least $2,000 worth of tickets must be sold. Our job is to write an inequality that describes this situation. So if we can't come up with an equation for 35, we're not going to be able to graph or solve it. So that's what we're going to focus in on here. We have 2 types of tickets, adults and students. So let's say I decide to let A represent adults. And I'll let S stand for students. Now, how much is every adult ticket? Well, it's $4 for every adult ticket. So I can write down the expression for A. If 2 adult tickets are sold, 4 times 2 would mean $8. 3 adult tickets, 4 times 3 would be 12. We can do the same thing for students. It's $3 for every student ticket, so plus 3s. And it says they want to make or cover at least $2,000. So the money coming from the adults and the students needs to be larger than $2,000. If it's smaller, they're not going to come up with enough money. Now we have an inequality that describes the situation. 4a plus 3s is greater than 2,000. If need be, you could move on to the next problem and graph it, and then you'd have your solution.